Okay, so we have a time and work question. Inlet, outlet pipe, constructive, destructive works, those kind of things. So let's read the premise here. A tank has inlet pipe and an outlet pipe. If the outlet pipe is closed, then the inlet pipe fills the empty tank in 8 hours. And the outlet pipe is open, then the inlet pipe fills the empty tank in 10 hours. Now, if only the outlet pipe is open, then in how many hours the full tank becomes half full? So whenever we have these kind of questions, I hope you do take certain number of units as the total work. That will always avoid fractions and decimals, easier to calculate with, also more accurate to calculate with. So in this case, we are going to assume that work, but also in case of these constructive, destructive work, so whether it is inlet, outlet pipe, or people, doing constructive work, destructive work, whatever is the total work of construction is the total work of destruction. So whatever amount of volume that is going to be filled to fill the entire tank, or whatever volume is required to fill the entire tank, it's the same volume that has to be emptied to completely empty the tank, right? So just keep that in mind and do not change it in the question. According to whatever the question is asking, we can adjust it, the total work done. So we'll just consider the total work of this particular tank, I mean the total volume in this case. So that will be 40, which is a multiple of both 8 and this 10. Right. So as soon as we do that, now if the outlet pipe is closed and the inlet pipe alone. So let's say the inlet pipe is IP or something. So the inlet pipe completes alone without the outlet pipe doing a negative work in 8 hours. So the efficiency is 5 units per hour, right? So that is what we are looking for. So the total work is 40 units. So the inlet pipe alone efficiency is 5 units. Also, when the inlet pipe and the outlet pipe is working together, so that is inlet pipe minus the outlet pipe, because the outlet pipe is emptying the tank. So the inlet pipe fills the empty tank, so the inlet pipe should have more efficiency. The amount of work is done in 10 hours, so the net efficiency is 4 units per hour. So now I think you can evaluate this quickly just by looking at this. Inlet pipe is 5, so this part is 5, and effectively we are getting 4. So 5 minus 1 should be 4, right? So the outlet pipe alone has an efficiency of 1, but obviously because it's an outlet pipe, so that is something we have as negative work, right? So that doesn't matter because the question would accordingly ask you. So as in this question, so you have only the outlet pipe is open, then how many hours the full tank becomes half full. So if the full tank becomes half full, we don't have to empty the entire volume, right? So this is what I said. I mean, depending on the question, you can change it accordingly, but don't change the total work. So we don't have to do the total work. We just have to do half the work, right? So the half the work is 20 units, and the outlet pipe is working with an efficiency of 1 unit per hour. So that will take a total of 20 hours to do the required work. So that should be the answer here. The answer is option A. So this is a very easy question. It should take roughly 1 minute to solve, not more than that. But if you are not good with it, it would take a bit of time. So depending on your comfortability, the time will change. But the ideal time to solve this question is somewhere in the approximation of 1 minute. So I hope that was understood and simple enough. Thank you.